Hey everyone! Today we're going to learn about income elasticity of demand for a good. Remember our lesson on shifts in demand? We saw that when income goes up, demand for a normal good increases. But if the good is inferior, demand actually falls when income rises. So what is the magnitude, the size of this change? We know that a change in income can affect demand positively or negatively. But does a change in income push demand a lot, a little, or barely at all? So how do we actually measure that? How do we measure the sensitivity of demand to changes in income? That's exactly what income elasticity measures, how sensitive demand for a good is to changes in income. It shows the direction of change, up or down, and also its magnitude of change. So how do we calculate it? Income elasticity equals the percentage change in quantity demanded, divided by the percentage change in income. The percentage change in quantity demanded is Q2 minus Q1 over Q1, final value minus initial value over initial value. Same idea for income. The percentage change in income is I2 minus I1 over I1, final income minus initial income divided by initial income. Q2 minus Q1 is just delta Q, the change in quantity demanded. And I2 minus I1 is delta Y, the change in income. So we can rewrite this as delta Q over Q1 divided by delta Y over I1. Let's simplify that fraction. Dividing by a fraction is the same as multiplying by its inverse, so this becomes delta Q over Q1 times I1 over delta Y. One last rearrangement, and we land on the formula we actually use most often. I'm just going to group the terms differently. Delta Q over delta Y times I1 over Q1. So income elasticity is the change in quantity demanded, divided by the change in income, times initial income, divided by initial quantity demanded. There it is, written a bit more cleanly. We can use this, the percentage change in quantity demanded over the percentage change in income, in its discrete form. Or we can use the continuous version using derivative, where instead of delta Q over delta I, we use the derivative of quantity demanded with respect to income times initial income over initial quantity demanded. Now, how do we connect the value we calculate for income elasticity to the sensitivity of demand? If you're enjoying the content, don't forget to subscribe to our channel. It really helps us grow. The bigger income elasticity is in absolute value. Whether it's very negative or very positive, the more sensitive demand is to changes in income, and the smaller it is, the closer to zero, the less sensitive demand is. So how do we classify a good based on its income elasticity? If income elasticity is less than zero, it's an inferior good. Quantity demanded and income move in opposite directions. If it's greater than zero, it's a normal good. And if income elasticity is greater than 1, we've got a luxury good. Worth remembering, every luxury good is a normal good, since its elasticity is positive. But not every normal good is a luxury good. What sets a luxury good apart from a normal good is that quantity demanded rises proportionally more than income does. By the way, I've got some shorts with definitions and classic examples of normal goods, inferior goods, and luxury goods. I'll leave them linked in the description if you want to check them out. Now let's work through 4 examples to practice this. Example 1. A 10% increase in income leads to an 8% decrease in the quantity demanded of margarine. What's the income elasticity? Income elasticity is equal to the percentage change in quantity demanded, which is negative 8%, divided by the percentage change in income, which is 10%. That gives us negative 0.8. Income elasticity less than 0, so margarine is an inferior good, which we could actually have guessed. If income goes up, it is natural to think that quantity demanded of margarine would go down. Example 2. A 10% increase in income leads to a 4% increase in the quantity demanded of chicken breast. Since income and quantity demanded move in the same direction here, we'd expect that chicken breast is a normal good. Let's check. 4% divided by 10% gives us 0.4. Positive, so yes, a normal good. But it's not a luxury good since the income elasticity is less than 1. Example 3. A 10% increase in income leads to a 25% increase in the quantity demanded of games on Steam. 25% divided by 10% gives us 2.5. So a normal good, but more than that. Since income elasticity here is greater than 1, games on Steam are a luxury good. If you're enjoying the content, don't forget to subscribe to our channel. It really helps us grow. Last example, suppose the quantity demanded of coffee at a university's cafeteria goes from 5,000 to 6,000 cups per week, after a 4% increase in students' income at that university. Calculate the income elasticity of coffee at this cafeteria and figure out which category of goods it falls into. So, what happened here? A 4% increase in income pushed quantity demanded from 5,000 up to 6,000. And what do we need to find? Income elasticity, the percentage change in quantity demanded, divided by the percentage change in income. The percentage change in income is already given to us, 4%. What we're missing is the percentage change in quantity demanded, but we can calculate that from the two values we have. Final value minus initial value over initial value times 100, because we want a percentage change. 6,000 minus 5,000 over 5,000. 6,000 minus 5,000 divided by 5,000 gives us 0.20. Multiply that by 100, and we get 20%. Now we just plug that into our formula. 20% divided by 4%. So income elasticity equals 5. So knowing that, how do we classify coffee here? Is it an inferior good, a normal good, or a luxury good? Income elasticity is positive, so we already know it's a normal good. But since it's not just positive, it's also greater than 1. Coffee turns out to be a luxury good too. That's all for today. If you enjoyed the video, don't forget to leave a like and subscribe to the channel. And don't forget to turn on the notification bell so you know when new videos are posted.